So hello everybody. I'm quite glad to share with you this technical aspect of aerosols in dentistry. But before I start, of course, I will present myself. As maybe most of you already know me, I'm not a clinician. I'm a scientist. And as a scientist, I carried out studies in chemical engineering first. And then I completed with a PhD in powder technology. And I spent 4.5 years only on powders. And then I tried to launch a startup company devoted on powder. And since 2004, I joined AMS as a powder and fluid specialist. And since then, I developed all the airflow aspects, meaning the powder chamber, nozzles, clinical application, and all that. And this includes, of course, all this aspect of aerosol generation. As you know, aerosol, powder, we are here in a divided material system, and that is all in the same line. And therefore, now I will focus on this aspect of aerosols in the industry. I think, okay. Now, I think that the subject of aerosol is now rised up now because of this coronavirus contamination. And this contamination makes a lot of noise. Many people discuss about it because we have this pandemic situation. And one issue related to this is the fact that this aerosol is spread from one individual to another. This virus is spread from one individual to another, mainly through aerosols. But when we speak about aerosols, what do we speak about? We speak about mainly saliva droplets, which are spit out and which, depending on the size, will spread close. If we have bigger droplet, it's a spit that we have during talking, for example, or it can go further. And therefore, we recommend to take some distance from each other and all that. When we are looking now deeper inside what is going on in dentistry, we have different publications looking at the problem of virus contamination during dentistry, because the virus contamination, it's not a new topic. It's a topic which lasts for decades. We had some different aspects with influenza, with other coronavirus in the past and all that. So that is something not new, that is something recurrent, and we have a lot of literature related to this. And here, this literature claims clearly that the contamination route is either saliva mediated or is a surface contact. Mostly is saliva droplets falling down on the surface, and then when we are touching this surface, we could be contaminated with it. And with this, we know that it's quite important. The saliva plays an important role on the contamination possibility of this virus. Now, when we look further, when we look further with regard to aerosol in dentistry, and that is where the concerns occurs, because now in dentistry we have different devices, the airflow, the piezo, the contra angles. We have all the procedure which use water to cool down the instrument, water to rinse off the surface, to get a clean area. So water is quite really important, commonly used in dentistry, and this water is spread off in small droplets. And now, the basic question is, what is the link of these water droplets, this aerosol in dentistry, and this virus? And knowing that the virus spread goes through saliva, I would add this saliva within this link. So before I go further, I think that we have to come back to the definition. Now, if we look at the definitions that we can see on Wikipedia or in different dictionary, it's claimed that aerosols are fine particles in air. This is a common definition, quite nice, but it's not sufficient. Me, as a powder specialist, of course, is not sufficient because just this definition will not help us to know what we need to do with it. And therefore, I like to bring you with me within a more precise definition of aerosols in order to better understand the problematic behind it. In fact, these fine particles can be either solid particles or liquid particles. And now, if we go in solid particles in air, we distinguish two categories. First is the smoke. Maybe if you have a cigarette, you create a smoke. This smoke is composed of some micro or nanoparticles, which are mainly below 1 micron. And these particles spray in the air and stays in the air. But then when we speak about bigger particle up to 100 micron, we more speak about a dust. So the smoke is not the same than a dust. A dust will settle down over time. And now if the particles are much bigger than the 100 microns, then they do not create any more dust because they settle down very quickly. And it's the same principle, the same idea for the liquid particles. But liquid particles are mostly bigger. And we have the fast settling particles, which are around 100 microns. And these particles will fall down. Then we have the true aerosol. And I would say really what we can really define as an aerosol. Aerosol are these micro droplets, mainly below 50 microns. And these droplets are good and are the real droplets for biotransport, because these droplets, if these aerosols, liquid droplets, are composed of saliva, then they can transport the virus, some bacteria, and that can spread the illness. And therefore, we understand now that we have really different meanings of aerosol, and it's really important to understand this definition, this different definition of aerosols. Now, if I go deeper and I look deeper in dentistry, I would say mostly what I face is that people mix the different types of aerosols, especially when using airflow powder spray systems. And in fact, this aerosol has 4 different meanings. And I think it's important to distinguish these meanings because each meaning has different property, different requirements. First, we have the solid particles that I previously defined as a dust. This is the powder itself. The powder creates a dust. This dust can spread away in the atmosphere, can deposit inside the office, and it has its own problematic. Then we have the second, what we claim also as aerosol, is a splatter. Splatter are these quite big water droplets spread in the air around the treatment area, and these settle fast and they deposit around the area. Then we have the device aerosol. In fact, effectively, the device creates an aerosol with the water which is used inside. But the device aerosol is mainly non-contaminated. And at the end, we have the treatment aerosol. And this treatment aerosol is what could be contaminated and what is under discussion. It's really important to understand the difference between all these types of aerosols, because these have different problematics and different way to address and to understand what is going on. If we speak about solid particles, here the major concern is the safety of the material. What is happening when inhaling in my lung? What is happening with all the system? Now, if we discuss about splatter, the main question about splatter is the contamination and is the dirtiness of the treatment area. Now, if we speak about device aerosol, meaning the non-contaminated aerosol, here it's non-contaminated as long as the water line are clean and that we do not take contamination from the water line. Here we have all the topic of the night cleaner, of keeping the dental water line clean and all that. And at the end, if we discuss about the treatment aerosol, it's there where we have the contamination question. What happens with virus, with bacteria spread? But I like with you now to go through to this different aerosol to better understand the problematic. But first, let's go to the airflow and to the link between aerosols and airflow. I think it's really important to understand what is happening in order to then distinguish and to address the topic in a true way. For the airflow, to remind you how it works, it's quite easy to understand, but I just reminded you. We have the compressed air. So compressed air cannot be contaminated with virus. This compressed air comes through a powder chamber and is loaded with powder. And then we have an air plus powder mixture. This mixture is spread on the surface. So we have air, so we have powder, and so we have aerosol, we have a dust aerosol. When the powder hits the surface, it's where the contamination could occur. Now, in this system, in order to avoid this dust aerosol spreading in the air, we add some water. And this water creates small droplets, create a liquid aerosol now, a true aerosol, which is around this powder aerosol and which goes on the surface. This liquid aerosol, having bigger droplets than the powder, is aimed to trap the powder dust and to avoid to have the spread of the powder dust. So that is the major aim of this water spread around the powder. And again, once we hit the tooth surface is once we start to think about contamination. So now with this solid particle, I think the topic is quite easy. We can address it easily, and we did it in the past, where we added here artificial nose. So we measure what we can inhale as a patient close to the treatment area, and just having a filter here, we can collect this solid particle and measure the amount of solid particle with regard to the air set out. And then we can have the data according to the composition of the powder. And with all that, we can determine, okay, is it dangerous? The additives that we put inside the powder. And at the end of this publication, of this study, we saw that it's completely safe to use these solid particles. So there is no problem with the solid material that we have inside the powder. So we have one question aside. But of course, now with regard to the contamination, question can arise saying, yes, but could bacteria or beta virus stick on these solid particles? And I would say if we use this consideration is now looking at what is happening with these solid particles. In fact, we have here two surfaces and we have a bacteria here. We have the particle, here I've taken the plus powder particle. This particle comes, these particles comes at a speed, the animation doesn't work. Yes, oof. These particles comes at a speed of 700 kilometers per hour on the surface and hits the bacteria. And we have 22 particles hitting the bacteria surface within 0.05 seconds. So here, what we see clearly is that due to this high velocity, due to this high impact, it's merely difficult for bacteria or for virus to stay on the particle. If we make the example in a normal world, what we can see here is we have here a bacteria, which is a man, and the powder particles is like a truck. So let's now imagine a truck coming on the wall at 700 kilometers per hour and hitting a wall here with a poor bacteria staying here. We have an amazing impact energy here and incredible speeds. So there is no risk of solid particle contamination. So no way for living material to stick on the solid particles. So that is of no concern here. So it's not a problem now with our powder. Now let's revise the second aspect, the splatter. The splatter is defined as big water droplet. We have here a treatment which is done without any suction, and without any suction we can see that we have a lot of big particles of this big splatter coming out of the mouth. This splatter, of course, they are quite dangerous. They're spread on the patient protection. It's what makes the treatment area dirty. It's sprayed on the patient goggles, on the user goggles. Also, you can see it clearly, and you can see that they are composed of course, saliva, of blood, of water. This splatter, of course, they are highly contaminated. They really comes and takes material out of the mouth. So that is, I think, really important to understand. Nevertheless, what is interesting to understand also is that the splatter contamination is only local. It stays around the treatment area. It doesn't spread in all the dental office. It's not possible because these particles are too big. And in order to manage, to take care about this splatter, it's really important to have a good personal protection. Face shield, a surgical mask, a head protection. The second thing, what is really important, is to have a high-speed suction tip. Is really to suck out at the base, at the beginning, where they are produced, to suck out as much as possible all this splatter. And third, it's where it's important to use a mouth rinse, because the mouth rinse is aimed to reduce the bacterial load of the saliva, and so the spread saliva has less contamination. And so using all this good practice will reduce the risk for the dental cabinet, strongly reduce. So you will just master this risk close to this treatment area. Of course, it's important after treatment also to clean well this treatment area in order to do not have surface contamination, which stays. But that is quite local, it stays local. Now, yes, just one remark to the high-speed suction tip, because here we have, for this suction, we have different wording. We have the high vacuum suction, we have the high vacuum evacuator, we have the high volume evacuator, the high speed evacuator or suction. All these means the same, in fact. In fact, what is happening is not that we have a high vacuum, but we have a high airflow rate. And due to this high airflow rate, we are able to suck out and to take away most of this contaminated substance from the mouth. Now let's revise the device aerosols. And the device aerosol is what's coming out from the device. It can be an airflow device, which generates droplets of around 50 microns. So it's the size of aerosols, or piezo device. but is it really contaminated? And in fact, not. It's not contaminated. This water comes from your unit, from the tap water. And in the tap water, you could not have virus contamination. Or I never heard that someone was contaminated just by drinking tap water. So virus doesn't stay in tap water. And therefore, this water is not virus contaminated. Of course, it will be recommended to have a clean water line in order to not bring up the algae or the bacteria that you have in the water line within the treatment area. But that is not related to virus contamination. So this device aerosol is not contaminated, so that is not a problem. So now let's jump to the contaminated aerosol. I think the aerosol which is of our interest. And now the major question is, what is the risk with this aerosol? And in order to address this risk, we can make some considerations, some estimations, some model, but I think it would be better to make some measurements. So if we do some measurements, then we are stronger to understand what is happening. And that is exactly what we did to try to understand what is happening with this contaminated aerosol. Here, what we did, we set up a method to measure this aerosol. So we have here a measurement unit. You can here see the funnel of this measurement unit. Through this funnel, we suck air with a very high flow rate of air, 900 liters per minute. So we have a strong flow going here inside it. And then we have a collection of this aerosol through a cyclone system. This will collect the aerosol and give us the opportunity to measure here from this aerosol generated during the treatment, what is really the contamination level? What are the real contaminations that we get? And so all the aerosol is aspirated in the measurement unit, or not all, but most of the aerosol, enough to be really representative of the overall aerosol generated. In our tests, we had some assumptions. First assumption is the high aspiration rate. Thanks to this high aspiration rate, we have a good aerosol collection. We estimate 80%, but it's not exact value. But it's most of the aerosol which is aspirated in the unit. Secondly, during 10-minute treatments, we measure 9 cubic meters of air. So we have a very good sampling on what is happening also in the dental cabinet during these measurements. Secondly, we place here our measurement unit 20 centimeters from the mouth. We have one practical reason for this, because you need to move around the mouth to treat. But secondly, most important, it will cut off the splatter. So here in this aerosol measurement unit, we do not collect the splatter because we are not interested here in the splatter, which are quite local and which should be mastered with personal protection. But we are here, the concern is a small aerosol which spread in the dental office and which can contaminate someone far from the treatment area. And therefore, we cut off the splatter. And then what we do from the collected aerosol, we measure the bacteria amount. We count the amount of bacteria. Why do we count the amount of bacteria? Because bacteria is an indicator for saliva. We can measure the amount of bacteria that we have in saliva. And now, knowing the amount of bacteria that we have collected, assuming that we have the aerosol was produced through the saliva, then we have, thanks to this bacterial count, the indication of the saliva. Now we know from the literature that the contamination of the virus is through saliva spread. And therefore, determining the amount of saliva that we have got during this treatment in the aerosol is an indicator of the virus contamination possibility of our treatment. We carried out 3 types of treatment. First is a baseline. Of course, we need to know where we stand from. This baseline, 10 minutes at the same location than for the treatment, but without treatment. So this gives us the contamination of the air in the dental office, but also the contamination of the manipulation. How clean we are in preparing our device for this bacterial test and counting. Then we have the airflow standard treatment. This airflow standard treatment was a 200 treatment. I just like to mention with airflow and with all this technique, 200 is more efficient for the suction, because you know when you treat with your handpiece where you are moving with your handpiece. And so it's the best way to best suck out all the contaminations that you have. And therefore, it's more efficient to work 200 for removing aerosol. Then we used a lip protection with Obtragate. We used a mouth rinse with Bacterix during 1 minute in order to reduce the bacterial load of the saliva. We used a saliva ejector, and we use this high vacuum suction, this big cannula. And then we did a treatment in worst condition, meaning, okay, we maintain this lip protection with Obtragate, and we just use a saliva ejector. We didn't use a mouth rinse. We didn't use the high vacuum suction unit. And here we have the results. And these results are quite great. We did it with 10 patients each in order to have a statistical representativity of the treatment. Here we have the CFU. CFU is a measurement indicating the number of bacteria. Here we have the number of bacteria, CFU per liter of air, is the bacteria inside the air. So it's the number of bacteria that we have in 1 liter of air. So you can imagine 1 milk bottle, and in 1 milk bottle here you have 1 bacteria. That is in order to understand what does it mean. Here we have the reference treatment, meaning the treatment just of the laboratory air. That is related also to normal air contamination. If we are looking in the literature, we see, okay, normal air contamination is around 1 CFU per liter, 1 bacteria per liter. So we are quite aligned with what happens in the literature, and we see that we are able to measure very small contaminations. Then we look at the standard airflow treatment. And with the standard airflow treatment, it was not possible to see difference with regard to the normal air contamination. This means that the standard treatment doesn't generate detectable air contamination. We do not contaminate the air with the airflow standard treatment, even if we think that we create a lot of aerosols with our powder, with our water. And here, very nice to see, it's a worst treatment condition. Worst treatment condition is a condition which was done without suction. And therefore, it's a condition where we saw the aerosol. I showed you previously the video where you see you have a lot of dust coming out from the treatment area, which is sucked inside the measurement unit. And we see we are able to measure effectively the bacterial load generated by this treatment modality. But what is, it's just here. This indicates that our measurement method is quite valid. It's able to detect contamination. And therefore, if we do not find contamination here, it means really that we do not have contamination here. And that is, for us, a quite great result. Nevertheless, now the next question arises. What does it mean? What is the quantification of these results? So in order to do so, I looked in the literature, and in the literature, there are some people trying to measure the amount of aerosol generated during sneezing here or coughing here. And out of this literature, they determined that one cough, one cough generates 1.1 milligram of saliva aerosol. Okay, that gives us a reference of one cough. Now, for our 10-minute treatments, if we measure due to the contamination that we have, and we measure the bacterial load of the saliva, we can measure the equivalent saliva amount that was collected in our system. And for the standard treatment, the equivalent saliva amount is less than 0.4 milligram. Less because I assume that I have a real value. I do not subtract the baseline from it. So that is the maximum value of saliva that is generated during 10 minutes airflow treatment. And in the worst treatment, without any suction, with a lot of aerosol generated around the treatment area, within 10 minutes treatment, we generate only the equivalent of 1.4 milligram of saliva. And you see, in relationship with one cough, we see that even in the worst treatment, we are on the same level than one cough. This means that, in fact, our airflow treatment generates lower contamination than social contact. So meaning, if I move forward this result, I can say I have more risk to be contaminated from the virus staying in the public transport than carrying out an airflow treatment. And furthermore, during the airflow treatment, you are well protected, and therefore this contamination level is very low. So let's move forward with further considerations. We have here the airflow. The airflow handpiece we see here generate an aerosol. This aerosol is a fine aerosol, but it's not contaminated. It's at the nozzle end that we have the finest aerosol because we have the highest energy, the air energy, able to generate this very small aerosol. Then we have the contact on the surface. We have seen previously, due to the particle speed, we have a possibility, a very high likelihood to kill bacteria and virus due to this impact contact. And then after this tooth contact, we have some water which is sprayed away from the system. But as we have the smallest particle at the nozzle end, the water droplet will collapse. And generally, the aerosol generated have bigger droplets, and so doesn't move very far away from the treatment area. And here you see the high suction unit. You are able then to suck out this contaminated area. If I move forward this consideration on piezo, on the piezo, and I did some tests by myself, although it's quite obvious. You have on the piezo, you have this curved tip, and you have a lot of aerosol generated on this tip due to the piezoelectric vibrations that you have on this tip. But all what is generated here is a non-contaminated aerosol. And that is the most of the aerosol. The only contamination possibility that you have is on the instrument end only, is in this treatment area. When you are treating the patient, when this area comes in contact with the saliva, with the tooth, it's here that you will have the contamination coming out of. And therefore, with your technique, with piezo, don't try to remove all the aerosol all these non-contaminated aerosol. Focus your suction unit on the tip end in order to remove really the contaminated aerosol. So to summarize, we have different types of aerosol, but not all aerosol are dangerous. We have 50% of the aerosol that we can see that we spread, which are with no contamination risk. We have the dust created by the powder. We do not have contamination risk with this dust. We have the water aerosol, the device aerosol, which doesn't create contamination. We do not have this contamination risk. So half of the aerosol, it's of no problem, of no concern. Half of the other half of the aerosol have effectively contamination possibility, but with low contamination risk, because we have the splatter. The splatter is where you have the most contamination risk, but this has only local effect. And this splatter can be well contained with good personal protection, with good technique, and using mouth rinse and all that. And now with the aerosol generation, we have seen that we have a very low bioaerosol generation. And that is also mastered thanks to the good technique, but the bioaerosol generation is very low, and it's much lower than just coughing. So in conclusion, with airflow, with piezo, yes, we generate aerosol, but the contamination risk of this aerosol is quite negligible. And so you can enjoy airflowing safely. Thank you for your attention.
Thank you, Marcel, for your presentation. It was absolutely clear. So in conclusion, we definitely can say that the first problem is really that there is kind of a misunderstanding of what is dangerous, what is not, basically, in the dental cabinet.
Exactly. And yeah.
Of course, there is a need for protection, personal protection. So definitely this is crucial anyway, but the aerosol is definitely less dangerous than what it could look like at a first glance. So we got few questions now. This is really like, probably you did it, but you probably didn't show it in the presentation. Have you measured bacteria arrays also by the use of high-speed turbine and the polish?
No, because here we started these tests with our means, and we focused first on the most dangerous, meaning the aerosol generated by airflow, because it looks like to be the more prominent treatment means. But we plan to continue to do it, of course, with different technique now in order to better address this problem. For me here, in fact, what I see is a confusion that we have with the different aerosol. And in the many literature that we can read, they do not really distinguish between the splatter, the small aerosol, and all that. And I think that is what we now try to add, this clarity between the different aerosol. And that is what we aim to do and to continue to do in order to better give a strong message about it.
There is one of the attendees that asked if it's possible to have some scientific references to the study that you quote in the presentation. Do you have any reference in the presentation, or eventually we can publish later on the event page?
So in fact, these results are internal results.
Internal results, okay.
We just produced it, but we produce it in the way to be able to write a publication. So I have written a publication. The problem here is, of course, your question is now. But if we wait for a publication in 1 year, it will be too late. And therefore, we decided now we share these results because it's important for you to see it. But if you like to have more details about it, I think it would be possible, or it will be shared soon.
Perfect. So let's say it's preliminary data from the research field, shared with some a little bit in advance of the publication, of course. So Okay, how sure are you that upon impact of the non-contaminated aerosol on the teeth, a greater percentage of the bacteria or virus are killed? For you to say that is it essentially safe, let's say that we can actually try to answer the question by re-explaining the concept related to the speed of the particle and the destructive effect that it has, basically.
Yes, that is a good question that we have also. And in fact, my question comes backwards, meaning now what I see, I do the treatment, I measure the contamination. And seeing that I have very low amount of contamination, then I start to think, why do we have this low contamination amount? And thinking on the mechanism, therefore I think, there is a link here. I agree, I need to prove it better, but just to the output, meaning the contaminated aerosol, or the amount of contamination that we have of the aerosol, we have a first indirect approval of this.
And therefore, we can expect the same effect that happens on bacteria to be effective also on viruses, which technically could eventually also be weaker in terms of resistance as a surface and membrane, right?
Exactly. Nevertheless, what I claim here is that we do not spray so much saliva in the air. We have seen from our literature review that the saliva is a mediator for virus contamination. And so if we do not have saliva spread, we will not have virus contamination. And it's not just one virus which will contaminate. We need a certain amount of virus. And so if we have a low amount of saliva, the virus has not the power to really contaminate.
I feel that a 10-minute window of airflow is unreasonable in a real-world setting. I use double suction and Optagate, and my face shield are always contaminated. Let's say something probably has to be specified from your presentation. You have, in fact, you focused your attention on the airflow, and very likely in the next presentation, we will put our focus on other part of the wall protection management of from the virus. But definitely, you talked about how much airflow is capable of destroying biological entities. Of course, and you will confirm it has to go along with the correct use of the double suction, because of course, we have to absolutely reduce anywhere is possible the airflow contamination. Am I right?
Yes, it is completely right. We need to have a good technique.
That's actually mandatory.
But to come to the question, maybe if I have understood one point, there was a problem of the face shield which was contaminated. Here we speak about cover, and that is the splatter.
Okay.
And therefore, you need to have a good personal protection. So my presentation doesn't tell you, you don't need to have a protection, there is no risk. No, splatter is dangerous. You have to take this personal protection, but it will be contained in just the treatment area and not away from this area.
And then eventually can be reduced with the proper use of the double suction eventually. But of course, the shield and all the protection, personal protection devices cannot be avoided for sure.
Exactly.
So let me go through the questions. Of course, there are some questions about the measuring, but of course, this is really like kind of a way to sum it up. Do you think that there will be a way to kind of measure the actual virus amount in the flow that you actually vacuumed? You called it the cyclone. Do you think there is any kind of a measurement or unit that we can try to hope to see that measure actual presence of virus instead of bacteria?
Of course, we are working on it.
Oh, perfect.
The problem is measuring bacteria is quite easy. So we could do it quickly, fastly, in order to give you some answer. But we will continue the research and focus also on virus. That this creates more risk, you know, for the environment. If we are playing with virus, it's more dangerous.
It's definitely this will be dangerous game. Absolutely dangerous game. But in the end, it's the dangerous game that all the dentists are playing. So definitely it's easy to expect that they would want to know if there is some sort of a direct measuration. Okay, there are some questions in details, and I just want to refer to the attendees. We will talk more about the actual procedures of protecting the operator, so the hygienist or the dentist, in the later presentation. So we're not going to talk directly with Marcel, so we try to focus on things specifically related to dust, powder, and aerosols and splatter. Maybe here again, how about mouth rinsing for 1 minute? How often should patient do it during the procedure to be efficient? Do you have any data eventually about the initial decontamination that can be done in the mouth, or anything to actually share with us about it?
So in fact, there are data in the literature already showing that it reduces the bacterial load. And I think it's an important and key parameter. Nevertheless, for me, the number one is a high suction unit, because these will really take out the aerosol and avoid that the aerosol goes out. So for me, the mouth rinse is a second level, meaning if something goes out, then it's already pre-decontaminated. But you know, saliva comes again, and so you recontaminate directly your mouth. So therefore, most important is a high suction unit.
Here's another question, interesting, but we kind of already answered. Do you prefer, and of course, I guess, do you think it's more efficient, high vacuum suction versus aerosol suction machines?
So if you think about the machine coming outside, I think these machines are not very optimum. And why? Because I think it's better to suck out directly at the treatment area, and where you generate the aerosol, it's more efficient than trying to collect all the aerosol. That is the first reason. The second reason is such kind of machine then needs to be decontaminated, because then you have the contamination coming inside, going to the filter, and maybe if the filter becomes old, they can go away. And therefore, I would prefer the real normal high vacuum suction unit. Will be more efficient, I think.
That's a very clear answer. And so again, sorry, but questions are coming up, and again, all the details about the treatment and the protection and the kind of mask, the type of mask, the N95 filters and so on will be already explained later, so I'm not going to ask those questions directly to Marcel. For those of you asking for the recording, yes, they will be available in the following days. So we will publish them if we don't have technical issues, of course. Hopefully not.
I read one question related directly to the results. Mm-hmm. In fact,
can you actually read also the question, because I'm kind of getting lost now by many.
How long after using the airflow you did the measurement? Oh. So no. We did the measurement during the airflow treatment. And our reference measurement are made after, before, and all that. So that are really measurements carried out during the treatment. So what the clinician receive in his face and all that. And the measurement is really close to the treatment area. So we collect at the source most of the aerosol. So it's during 10 minutes. So 10-minute airflow for full mouth treatment that we collected the aerosol generated during this treatment.
This is kind of in between technique and splatter problem. So with regard to splatter contamination, does it mean we should change PPI after every patient? Technically speaking, if you're using a shield, the shield might be decontaminated eventually. But of course, this is, let's say, one thing before being eventually unclear. We are just talking about, generally speaking, every country will have or already have specific regulations. So we're not talking over these country regulations, definitely. This is really something related to every state. But
in fact, you have to clean, you have to be aware that you have this contamination coming on you. So there are some publications showing that with glasses you can whip it out with alcohol, and then you reduce completely the contamination. On clothes, I don't think that you are able to reduce the contamination. But okay, that is, I would say, standard practice.
Exactly. And of course, again, everything has to be reconducted in the specific laws of every country. Unfortunately, we cannot actually go through all of them because it's a little bit of a huge work. So we definitely are talking about the technology, the actual problem as it can be measured, and eventually some suggestions that are common practice. And so basically we are going through the same question. Again, you mentioned that good suction technique controls aerosols, and we will talk more in detail about that very likely already with the next speaker. So I'm not going to ask Marcel anything about that. Okay. So basically, I would say that this is it. So we go through mainly because, of course, there are some repetition. Yes, I would say that we answer most of the questions. And in your opinion, Marcel, what you saw from general dentists, if you had the chance to get some feedback from them, what is the most common fear they have and what you could eventually suggest them to do, even if you already explained something in the presentation, but it's really just to sum it up before passing to the next speaker?
For me, the fear is clearly related to the aerosol. Will I contaminate the patient and myself also in the dental office? And for me, this fear is mainly linked to just general understanding of aerosols. And therefore, I tried in my presentation to make it clear in order to understand what are the real danger during the treatment. And if you understand this, I hope this can reduce the fear because you know how to address this. An enemy, an unknown enemy, it's more terrible than an enemy that you know and that you know that you can master it.
So definitely the two big enemies are aerosol and splatter. So those are the two big enemies of the dentist, and you have to take care of them both.
Yeah.
Perfect. Thank you very much for your presentation, Marcel. It was very interesting, and we're looking forward to hear some of the results or updates on the results, of course, and eventually have you for our next webinar again.
Yeah, exactly.